So here we have two objects, two blocks, M1, M2 mass, and the first one is moving to the right, second one is moving to the left, and there is a spring between these two objects. So first question, we should find the velocity of the second object, second block, when velocity of the first block object becomes 3. Let me try to draw. So this figure is before collision, after collision, or at the instant when velocity of the first block equal to 3, basically. So due to the spring, during the collision, the velocity will change. So let me try to draw here. And this is a spring, and we have a compression here. Compression is happening. M1, M2. At this time, velocity of the first object becomes v3, which is 3 meters per second. At this instant, at this time, we should find velocity of the second object, v4. Everything is given, mass v1, v2, v3. So again, let me draw my x direction. Let me choose it to the right. So momentum impulse with direction to the right will be positive again. So due to the conservation of momentum, total momentum before collision should be equal to total momentum after collision, or at any time. So again, momentum is a vector quantity, but here we have a collision in one direction, so only in x direction. So there is no need to worry about the direction. I mean, it's not going upward or with a certain angles, just horizontal momentum. So initially we have two momentums. So first one, M1 V1, momentum of the first object. Second one's momentum M2 V2, but with negative sign here because it's moving to the left, opposite to our chosen x direction. So this is a total initial momentum of the system. After collision, or at certain time, the first one will be moving with velocity v3 to the right, it's given. Second one, we don't know in what direction it will be moving, but let me assume it will be moving to the left, as I show it here. That's why I will put negative sign here, because I think it will be still moving to the left, but at the end we will check it. That's why we have a negative sign, because it will be moving to the left. Okay, let's continue. So V4 from this equation, from this formula, will be equal to M1 V3 plus M2 V2 minus M1 V1 over M2. So mass 1 equal to 1.6, V3 is 3 plus M2 2.1 kilogram, V2 4. Just magnitude here we are using just numbers. 1.6, velocity 4 over M2, which is 2.1. So from here V4 will be equal to, we need to use our calculator, 1.6 times 3 plus 2.1 times 4 minus 1.6 times 4. Sorry guys, V2 equal, it's not equal to 4. V2, it's not equal to 4, it's 2.5. It's 2.5, sorry. M1, V3, M2, V2, yes, there is a small mistake here. Let me do it again, my calculation. So it's 1.74 approximately, 1.74 meter per second. So I have here positive number. It means, yes, it will be moving to the left. And there is second question. We should find the compression of the spring at this time, at this instant. So this part we can solve by the conservation of energy. We know that total energy initial of the system should be equal to total energy final of the system. Final is the moment when velocity of the first one 3, second one's velocity 1.74. So initially both blocks moving, it means we have two kinetic energies plus this is the total energy of the system before collision. After collision, or at the instant when they are moving with velocity 3 and 1.74, so we have again kinetic energy of two objects, two blocks. And also at this time spring will be compressed, so spring has a potential energy which is kx squared over 2. This x is a compression, so we should find this compression. We have only one unknown in this equation. We can remove 2. So x equal to square root, basically m1 v1 square m2 v2 square minus m1 vc square m2 v4 square over k. So that's all. M1 is 1.6, initial velocity 4 square, M2 2.1, its velocity 2.5 square, minus 1.63 minus 2.1, its velocity 1.74 square, over spring constant equal to 600. From here x will be equal to, so final answer is 0.17 meters, or in centimeters it will be 17 centimeters. This is a compression of the spring.